Good evening, everyone. Welcome back to our 30 days free short term prime. So, guys, what did we learn yesterday? Yesterday, we have understood the concept of KNN, right? KNN algorithm was being discussed, and we are supposed to work out on a project today with respect to K means. I mean, KNN, right? So, before that, before we go and understand the project with respect to KNN, we'll quickly revise what we have covered with respect to KNN, right? So KNN stands for K nearest neighbors. So depending on the nearest neighbors, you know, depending on the K nearest neighbors, it actually predicts for the new data point. That is why it is named as KNN, K nearest neighbors. Right. So KNN is nothing but it's a lazy learning algorithm. It's an instance-based algorithm. The reason is it is not learning anything from the trained data. From the trained data, it does not learn anything. Just it captures the entire trained data. It stores the trained data as part of the training process. Then, how it is capable of predicting? It is the simplest algorithm of machine learning, where it uses the distance logic. It uses distance logic for predictions, right? So, by default, we are aware of Euclidean distance. If not, we can also go with Manhattan distance, Minkowski distance, Mahalanobis distance. Any of the distance formula can be used for predicting the new data point for the predictions. In simple, for predictions. Right. Now, the question is, if it is capturing the distance with the new data point and the existing data points, depending on the value of k, depending on the nearest numbers, what is the nearest number it is the k is taking, okay, it is going to give the same class with respect to the new data point as well. See, supervised algorithms are generally of two types. One is classification and the other one is regression. Classification is nothing but where we have discrete values in the y column, and regression is for the continuous data. If the you know if the y value are continuous, so then it is we are supposed to use k nearest neighbors regressor. KNN can be used for both classification and regression, friends. Yesterday we have understood with respect to classification, right? See, if a new data point comes, we are actually identifying or calculating the distance with the existing points, and depending on the k nearest neighbors, k value, we are predicting for the new data point, the category, what is the output. Okay, so if you have a particular class repeated for majority of times, that class will be the output for the new data point. Perfect. Akhil, what in the case of regression? What if I'm, using KNN for regression? Can KNN be used for regression? Yes. KNN is part of shallow techniques. Okay, so shallow techniques we have naive Bayes, KNN, decision tree. So all of these three can be used for both fronts. Either for classification or regression, you can use these algorithms for both the tasks. Right. So let us assume that we are also working on regression case. The same process, yes. The distance will be calculated, everything is done. But here, it is not the discrete values, right? We have continuous data. What are we supposed to do in this case? Depending on the nearest neighbors, it takes the nearest neighbors y values and it performs average. It gives the average with respect to regression task, right? So I think this was also understood with respect to the slides, the content that was discussed yesterday. And today we are going to work out on a project, as we have discussed, end-to-end project. The last project of this particular program is we are going to predict whether a customer will go for personal loan or not. Okay, so predicting whether a customer is going to opt personal loan or not. So this project is with respect to banking sector, friends. Yesterday I have discussed that we'll be doing a project on life sciences healthcare, but you know we are actually going to discuss the same algorithm in the next algorithm, for the next topic. So for this particular topic, we have banking sector use case. This was a real-time project that we do in banking sector, predicting whether a customer of a particular bank, there was a bank XYZ. Okay, so let us name it as XYZ, and this bank will have obviously some customers. So what banks do, they'll come up with the different programs. They'll not sit idle. If they sit idle, where is their revenue will be generated? I mean, revenue in the sense they want more profits, right? So they'll run some kind of pilot projects. Okay, they'll come up with some campaigning. They'll do some campaigns. So out of one of the campaign that I have done, so we have this project. So this project is the customers of this XYZ bank, will they opt for personal loan or not? Okay, so this is again a classification problem. So we have only two classes, yes or no kind of thing. Okay, so let us go with this use case, friends, and we'll also discuss the parameters, what the evaluation metrics for supervised learning, because the evaluation metric for unsupervised learning with respect to clustering was discussed is Silite score, right? In the same way, we have uh, what Kalinsky Harba score, okay, Davis Baldwin. There are n number of metrics, but we have understood only one, that is Silite score. In the same way, even for classification problem under supervised learning, there are some evaluation metrics. So we are going to understand it today in the class. Right. So this particular problem is with respect to classifying persons, the customers of a bank. Okay. So whether they are going to opt for a personal loan or not. Right. So there are around 5,000 observations, probably 5,000 customers. So observations are nothing but record strings. Each record talks about a customer, right? And there are in total 14 variables. So 14 variables are nothing but 14 columns, 14 features. So let us understand all the features before we dive into the project. The first one is ID. So ID of the customer. This ID column refers to the ID of the customer, right? So for each and every customer, this ID gets changed. It's a unique number that that will be given to the customer. Then age of the customer, in years. What is the age of the particular customer in years? Then experience. If a particular customer is working, and if they have, if they are working in any domain, we are also capturing their work experience in years again. Income. Okay, so amount of annual income in a year. What is their income? We are going to track, we are going to have the information under this income column in thousands, friends, in thousands, right? Then zip code is nothing but the postal code, pin code. Okay, so where the customer is living, we are also tracking their zip code. We have the information. Then family, number of members, number of family members in that particular family. If the customer is married, okay, so is the customer single, or there might be different cases, right? So we are also having the information of the family members. Then CCAVG, credit card average monthly spending with the credit card. So you know, uh, credit cards, like how we have debit cards. Okay, so people who are using debit cards, in the same way, if you are earning, if you started earning, you'll get some kind of credit from the bank, depending on n number of factors: CIBIL score, your transactions, okay, like your payment history and all. You'll get some kind of credit cards. Some credit will be given to you. You can use that credit, and you're supposed to pay the credit, you're supposed to repay it before a certain time. A time period will be given to you, and you're supposed to repay it, right? So we are also identifying how much is the customer spending on an average with respect to month. On a month, from this credit card, if a particular customer has credit card, how much he or she is spending on average with respect to month. So again, this information is also recorded in terms of thousands. Then education, what is the education level of the customer? Is it bachelor's? If it is bachelor's, we have it with one. If not, if they hold any master's degree, we have it with respect to two. Then if they are again professional kind of PhD, or beyond masters, say double masters, then we have it as three. Just to maintain their education level, we also have it as, we have the data. Then mortgage. Mortgage column has the value of their home loan, if they have any kind of home loans. So we are also having the information in thousands. Then security accounts, I mean, if the customer has any kind of securities account with the bank, we are having the information. Then CD account, nothing but is the customer having any certificate of deposit account. Okay, so is the customer depositing anything with respect to an account? So we have the information recorded. All these are required before we give a personal loan. So out of these columns, some are not required, so those columns we may drop off. Okay, so that is called as feature engineering. We'll discuss. Then next one, online. So online refers to, in nowadays we see UPI payments and all. Previously, online transaction is nothing but internet banking, friends. So is the customer is actually using that internet banking facilities or not? That data was being recorded under online column, online feature. And finally, credit card. You know, so is the customer having any credit cards? Is the customer maintaining any credit card that this specific bank issue? Okay, not by other banks, by this bank XYZ. So all these columns are nothing but are inputs. All of them are inputs. The data that we have. The final column is personal loan, the target column. Okay, so the label column, the Y column, that is personal loan. So did the customer accept the personal loan that we have offered? We being part of bank, we approach our customers and we'll say, sir or ma'am, are you interested in taking any personal loan? So this will be your rate of interest for the next 10 year. This will be rate of interest. Each and every point will be communicated, and we are supposed to make our customers accept the loan, so that at the end of the day the banks get revenue, profits, more profits. Okay, so as part of the loans they get interest rate, so obviously they'll get profit, friends. So the data has been recorded, and Why are we going to build a model is, if you build a model, this model can be used to predict on the new data. In future, if I run a similar kind of campaign, okay, obviously I'll not run the campaign on the same people, same customers. I do it on the different people, new people. So for the new people, I'll pass the new people, new customers data into this model, and this model upfront tells me whether the customer will uh, accept the loan or not. So if it says no, what is the meaning of approaching such kind of customers? But in case if it says yes, yes, this customer will accept our personal loan. Okay, if you get such kind of solution, if you get such kind of answer from the model, that y is equals to f of x equation, obviously we are supposed to target those customers so that our profits will be increased, right? This is how machine learning is used in banking sector. I was talking about only one specific department, friends. This is respect to with one specific department. So in banking sector also you have many departments. Okay, so probably the department who is looking after personal loan, so one department, there will be separate department for loan, personal loan, home loan, then what all, uh, car loan. Okay, so education loan, there are n number of sectors, right? So depending on all of these, ML is used. If the data is recorded, they can use ML, right? We can apply ML on the data and we can build a model for prediction, right? I hope you have understood the features. Now let us actually jump into the use case, okay, by specifying the data. Okay, so before that, I'm supposed to import some required libraries, pandas for data manipulation, then pandas profiling. So this pandas profiling is nothing but it's an automated EDA package, friends. If you remember in the last, probably in the last project that we have understood with respect to k-means, okay, so we discussed an automated package, EDA package, nothing but SweetWiz. Akhil, we have understood SweetWiz, right? What is pandas profiling? SweetWiz pandas profiling. Okay, there are again multiple detail. Okay, AutoVis. All of these are multiple automated EDA packages. So, what is the use of these packages? They automate the process of EDA, friends. They automate the process of EDA. So what do you mean, Akhil? I mean to say that, you know, the entire EDA process that we have understood, first moment, second moment, third moment, fourth moment, data visualization, univariate, bivariate, all the plots on all the columns will be done by this EDA package, automated EDA package. So should we start doing should we start learning these auto EDA packages? So my answer will be no, friends. The reason is, if you are a fresher, don't start learning these packages. The reason is your works, whatever the work that you have, your work gets very simple. It makes your work simple. So what you are going to learn at the end of the day. So my humble request, being a fresher or being new to this particular technology, uh, so don't do it using automated TDA package. Do it manually on each and every column so that you learn initially. Once if you are familiar with the skill, then go and use these libraries. No one will stop you, right? So let us understand how this pandas profiling we are going to use it. Then matplotlib.pyplot, importing pyplot from matplotlib. So this is for visualization, friends. Okay, then comes the function K neighbors classifier. Since we are going to work on a classification problem, so K again it is a KNN algorithm. The function is K neighbors classifier, which we are importing from sklearn dot neighbors. This is a package. Okay, then from sklearn.metrics, I'm importing classification report, confusion metrics, accuracy score, and all the functions. So these are nothing but some kind of uh, what evaluation metrics used in classification problems. Then SMOD is for handling imbalanced data sets. Okay, what do you mean by imbalanced data? Friends, do you remember what is an imbalanced data? Probably we have discussed in 13th or 14th session of this program, if I'm not mistaken. 13 to 15 it will be around. What is imbalanced data? Don't say data which is imbalanced, it becomes imbalanced data. Hmm. What is imbalanced data? If you remember, we have discussed the characteristics of data: structured, unstructured, big data, no big non big data, balanced, imbalanced data. Any idea? Unequal number of observations. Good. But what do you mean by unequal? See, target column having unequal number of observations is the answer that I got from one of our friend. Okay. So unequal number. Can you please justify it? If I'm working on a binary two class problem, there are two classes: pass, fail. Okay. So in assume that I have 100 rows. Okay. So 90, 10. This is unequal. 80, 20 unequal. 70, 30 unequal. 60, 40 unequal. So all of these are unequal. One class having more data points than other. So this is also, so all these, do you mean to say unstructured? I mean imbalanced? Sorry. Do you mean to say are they imbalanced? Because one class having more values compared to the next class, compared to the other. Hmm. 90-10, obviously satisfied. What your explanation, whatever the answer that you have gave, my friend. So 90-10 is satisfying, 80-20 is also satisfying, 70-30 is satisfying, 60-40 is satisfying. So you mean to say data is balanced only if they have 50-50. Only this is where we say data is balanced. In rest of all the cases, is data imbalanced? This is very important. The reason is, excuse me, in classification problems, that is the reason I have, told you on day one itself. Basics are very, very important. The reason is, in interviews, the basics will be targeted initially. If you don't answer the basics properly, immediately they'll say bye to it. Okay, in classification problem, since we are working on discrete values, discrete data, we are supposed to do what? We have to check whether data is balanced or imbalanced, because we'll have fixed values: cancer, no cancer. So cancer is one class, no cancer is the other class. So before you train a model, you are supposed to check whether the data is balanced or not. And if you don't check the data is balanced or not, your results, assume that you have built a model on imbalanced data, your results will be worst. The reason is the model gets, you know, biased. The model gets influenced to the class to which it has more number of values. For example, out of 100 records, 90 records I have for cancer and 10 records I have for no cancer. So 90 patients have cancer and 10 patients have no cancer. They don't have cancer. So on the same data, as it is, I'll go and build a model. This model that gets trained on the trained data, it gets influenced by the top class. I mean, the class with majority of the values, and whatever the record that you pass with respect to the new data. Okay, if a new patient comes in, okay, and if you pass the details of the new patient to this model, it obviously says, yeah, this patient have cancer. Same. The reason is it gets biased. For that reason, what did we discuss? This imbalanced data should be converted to balanced data. We have to balance the data. If not, there is no use of building a model. Right, friends? So, balanced data is something very important, especially if you are doing a classification project. Okay, so even if you just understand, if you understood this particular project with respect to KNN, you can download or you can work on any open source data which is available online, and you can build your own model. But make sure the data is balanced before you actually go and build a model. Right. So balanced data is the data which is nothing but each and every class, each and every class present in the data, present in the by column, in the target column, should have at least 30% of the values. Should have at least 30% of the values. So if you take 100 records, this is imbalanced. This is also imbalanced case, but this is balanced. 70-30. At least 30-30 is matching. This is also balanced. I hope it's clear. These are not imbalanced means these are balanced. Right. So why am I importing SMOT is? SMOT is a technique. It's a what synthetic minority oversampling technique. SMOT stands for synthetic minority oversampling technique. So generally, if you are aware of undersampling, oversampling, undersampling is it reduces the samples, oversampling is it increases the samples. But SMOT, it generates, okay, it generates new synthetic minority class. Whatever is your minority class, okay, for the minority class, it comes with some oversampling technique. Okay, so SMOT is an technique which is used for converting imbalanced data to balanced data, and it's an oversampling technique, friends. It performs oversampling technique. Right. So standard scalar is for feature engineering. I mean feature scaling. Then finally, train test split is for splitting the data into train data and test data. And we also have grid search CV. This is for hyperparameter tuning. So what is this hyperparameter tuning and all we'll discuss. And finally, joblib. Joblib is for saving your model. Okay. In order to save your model, you cannot save it in the .py file, right? You have to save it. Okay. So we can save the model, or we can load the model again back using joblib and pickle libraries. There is a library called pickle. Okay, pickle. In the same way, we also have similar library to pickle, that is joblib, which is used to save and load models. that we actually build. So what is the use of joblib? You'll understand tomorrow, not today. Probably tomorrow, since we'll understand deployment tomorrow. So how joblib will be used, you can probably understand them tomorrow. So let me execute all of them together. So all of these libraries have been imported. Then I'm reading the data which is present in this location in my local system. So I'm reading the data, and the data is present in an Excel file, friends. So read underscore Excel will be the function from pandas, and I'm storing the data in df variable. This is my data. So data frame, a two-dimensional object, rows and columns. It contains rows and columns. 5,000 rows and 14 columns. My bad. 5,000 rows represents 5,000 customers. 14 columns represent their features of 5,000 customers. ID of the customer, age, experience, income, zip code, whatever we have understood. So, these are the columns. Out of 14 columns, 13 are inputs. Again, we did not do feature engineering. So if you do feature engineering, you can identify the required features, whatever might be the required features, you can identify them and get the required features, required inputs. And your target variable, your Y column is personal loan. Either, the customer accepted. If they accepted, you'll get 1. If they rejected, you'll get 0. So 0 and 1 is representing that, friends. Okay, not everyone will accept the loan, right? So majority of them you'll see zeros. So that is the reason Kaggle. See, whatever data set I'm explaining, okay, it is available in Kaggle, but I do some kind of changes because I'm implementing a real-time project, right? So obviously, with respect to the code and all, I'll come with some kind of professionalism. So try to replicate the same. You'll have n number of data sets in Kaggle. I am telling you the same thing from day one, right? So it is available in our open source sites like Kaggle. Right. So this is why our Y column, friends. I hope the context is very clear. We are going to predict whether the customer will accept the customer accepts personal loan or not. If they accepts, that means we'll keep it as 1. If they reject, we'll keep it as 0. For that reason, upfront I have some historical data. Using this historical data itself, I'm building a model using KNN algorithm. KNN algorithm is completely dependent on distance based logic. Alright, so let us start the project, friends. Head function. What does head function return? What does head function return? Head function returns the top records. By default, it will be 5. Even though I'm specifying 5 records, so I'll get the top 5. So these are the top 5 records of my data, and I can see them with respect to the head function output. Then info function, friends. Yeah, by default 5. Yes, good. What does info function return as? Info function will give you the information about the data set. It talks about number of rows, number of columns, then the non-null count. It talks about the null values and all. See, 5,000 entries, 5,000 rows, and these are the index for the 5,000 rows and 14 columns. And here is the list of the column names and followed by the non-null count. And what else can be understood? The D types, data types for all the columns. By just looking at the output of info function, what can you comment? Do you find any null values in the data set? Your answer should be yes or no. That's it. Any null values? No. There is no null value present in the data set. Not even a single column has null value. So I need not, work on handling missing value step with respect to data preprocessing. Am I right? Yes. No null value. But before we start model building, we should not, you know, uh, jump here and there. We should follow the process, the crisp MLQ methodology. The first step is understanding the business. We understood it. The data understanding is done. So followed by data understanding, we are supposed to perform EDA. In order to, we have less number of, we don't have more time. So that is the reason we are going with an automated package, that is pandas profiling. So you are supposed to just pass the data, friends. Okay, and give a title to the particular output. So let me execute it. It have stored in the profile. It got initialized. Now this profile I'm going to use it on the data, and I want to get the output to a HTML file. I want the output in a HTML file. I'll execute and it starts. So focus on the console, you'll understand. See, it's taking time. In the backend, it summarizes the data set. It is showing the percentage of what is done and not in the range of structured report is being generated. Then we can also render the HTML. Yes, this is done. Akhil, you told us that we'll get a HTML file, right? Where is the HTML file? Where is the output of EDA, automated EDA module library? Yeah, I told you that we'll get a HTML file. Yes. Then where is it, Akhil? Friend, when you are running these particular lines of code, the output will be stored in current working directory. How do you get the current working directory in this box? No, I just want it in HTML file so that I can open the output in any of the browser. If you don't want to have it in HTML file, it allows you to display the output in any of the format, friends. So that's why you have to go to the documentation of pandas profiling. Okay, so if you go to the documentation of pandas profiling, you can give your own format. For me, I'm comfortable with HTML. Okay, if you are interested in any other format, you specify that particular format, then the output will be stored in that particular file format that you have specified. Okay, so this is called as current working directory. So in this particular location, I have the output. Okay, so I'm opening that particular file. So this is my current working directory, and what is the time now? It's 7:37. So this is the HTML file. If I double click on it, it opens in a browser. So what is the output? The title that we have given, Pandas Profiling Report. That's what I can see the title for the report. Then it talks about the complete, you know, overview of the data set, friends. Number of variables out of 14, how many are numeric, how many of them are non-numeric, categorical. Then number of observations, rows, missing cells 0, missing cells percentage. If it is 0, obviously this will be 0. Duplicate rows, is there any duplicate row? 0. Duplicate rows percentage 0. So how much memory it is occupying with respect to size? 547 KB. Okay, so in this way, it is giving you each and every information with respect to the data set, the statistics with respect to the data set. Okay, then let me go with each and every variable. Okay, we have the list of variables, nothing but the columns. You can understand each and every variable to the depth. That is the reason, nowadays automated EDA packages are getting very famous. Who is going to spend lot of time? Am I right or wrong? If my data set has 50 columns or 100 columns, okay, can we expect 50, 100 columns in real world? More than that, you'll have friends, especially in finance, banking sector. Not only in banking sector, life sciences, healthcare. Okay, so if you take these domains, you'll have more number of features, more number of columns. So if you want to do EDA on one particular project, it takes our lifetime to do it. For that reason, nowadays automated EDA packages are, trending. Right. So let us talk about what information it is providing with respect to the columns, the features. How many of them are distinct? All of them are distinct. The percentage with respect to the distinct. Okay. And missing is zero. Okay. And do we have any infinite value? No. The mean, since it is an ID column, as we have discussed, it will be a unique number given for each and every customer. So the minimum value is 1, maximum is 5,000, and we also have the min max values here. Zeros, do you have any zeros? No. How many, percentage with respect to zeros? Again, it is 0. How many of them are negative? 0. Negative percentage is 0. So what is the memory size with respect to only this particular column? It is 39 KB. And this will be our, you know, histogram, right? So probably there is no use of looking at ID column. The reason is it's a nominal data. Nominal data in general should be ignored. Okay, if you go and look at age, yes, age is something that I have to consider because age is an important factor that I have to consider with respect to this particular use case. Will you go and probably give or provide any personal loans to people who are above 60 years? No. What is the use? They become old, and how do you moreover offer such kind of for such kind of people? Rarely that may happen, but in general, no. Whoever might be in the age gap between probably 25 to 45, they take more personal loans, right? So yes, age is an important feature that has to be included, but when it comes to ID, will ID affect output? Is there any kind of relation between ID, customer ID, and our output, personal loan? No. If your ID is one, will you go and opt, will you go and purchase, will you go and accept personal loan? Foolishness. So this is called as feature engineering, friends. Feature engineering is nothing but we do some kind of analysis on the features. How relevant is input to the output? If it is not relevant, what is the use of having that particular input in the model building part? Not required. So we can ignore such kind of columns. That is what we do as part of feature engineering. Okay, so we'll discuss again. We are deviating. Let us not do that. So if you want to spend enough time on this particular report so that you get the information about each and every column. Okay, so if it is categorical column, I see a horizontal bar plot, because categorical columns are generally, since they are having discrete values, you can expect a bar plot. So what is their count? Everything we have it over here. Excuse me. Credit card, how many of them have credit card and how many of them don't have credit card? Okay, then personal loan, how many of them have accepted? 480. How many of them are rejected? 4,520. For 5,000 customers, what will be 10% of the data? 500? Yes. 20%? 1,000? 30% will be 1,500. So what is the rule? When can we say that the data is balanced? If all the classes, if all the categories present in the Y column, target column, output column, if they have, if each and every value has at least 30% of the values, then we can say the data is balanced. I don't even have 10% of the values. 10% is 500, but how many of them have accepted? 480. Data is imbalanced. I can clearly see that data is imbalanced, and I have see it's even clearly mentioned imbalance. I have to balance it, friends. How? Yes. So we have to apply some kind of techniques. In general, we also go and apply k-fold cross validation, SMOT, then sampling techniques, undersampling, oversampling, modified SMOT, stratified k-fold cross validation. There are n number of techniques. Whatever we are learning is just a bucket. There is an ocean. Okay, so don't assume that we have learned everything, right? But in real time, SMOT, k-fold cross validation will be used or will be preferred generally more compared to other techniques. So out of these two techniques, we are going to learn, we are going to apply SMOT on the data fronts, right? Then we can also interact with, particular columns. So this is an additional advantage that we are getting. ID with mortgage, say age with mortgage. Okay, so the correlation chart can be understood. Correlation, smaller. Okay, so is there any column which is highly correlated? If it is highly correlated, you will see, uh, you know, that particular square in dark blue. So obviously the diagonal should be in dark blue. The reason is the diagonal is representing correlation with the same column, ID with ID, age with age. But I see age and experience are also correlating more, because this is for experience and in the same way it is for age. So seems like age and experience. Obviously, if you have more age, you'll have more experience. If you are a fresher, obviously you'll have less age. How do you have experience? You will be fresher. So I can clearly observe it from this plot that age and experience are correlated. I see a strong correlation. It's near to one, close to one, right? So again, missing values. Do you have any missing values? I am able to get the missing values data with respect to a count plot, and I don't see missing values. And here is the sample data, friends. The first 10 rows and the last 10 rows. It is also displaying the sample data from the original data. Since this is a new topic for us, I was investing enough amount of time to explain all these things. But if you are generally new to this particular, particular technology for this domain, you don't go and start using these auto EDA packages. The reason is you will not learn more. When you do manual EDA, you have to write the logic for mean, median, mode, first moment, second moment, third moment, fourth moment, including visualization. Everything you have to write the code. That will enhance your skills. But just writing only 2 lines of code and getting the output, I don't think it will work in the initial stage. But in future, yes. When you got enough practice, when you're done with enough hands-on, so you are supposed to go and use the automated EDA packages. There is a question from one of our friends: what to do if two features are highly correlated? In KNN, it does not affect, but in other algorithms, yes, we are supposed to remove or in some cases there are multiple techniques again. In some cases, we actually drop off one of the column. So highly correlated, right? So this is nothing but duplicates with respect to column. If you remember, in data pre-processing step, we understood duplicates with respect to rows. How to handle duplicates with respect to rows. But at that stage, did we also talk about duplicates with respect to columns? No. Okay, this is nothing but duplicates with respect to columns. Age and experience are, you know, holding the same information. How? More age, more experience. More experience, nothing but more age. So obviously it is a duplicate with respect to column level. Right? So with KNN, you will not have any, I mean, especially for KNN algorithm, there is no kind of assumption that column should not be uncorrelated. You can proceed, but with respect to other algorithms, it does not give you good results. There are other techniques that we actually implement to remove or to drop off one of the column. If not, we go and calculate VAF, variance inflation factor. We also get the influential observations. So multiple techniques, friends. It's not one technique that we follow. We'll try experiment all the techniques. Only one relation to be considered. I did not get you, my friend. What is your question? Only one relationship to be considered. What relationship? Here, uh, our friend says age and experience are correlated, right? So, should we, what are we supposed to do is the question from our friend. I was explaining for that point, right? So, whatever the insights that I have found, I have kept all the insights in some kind of comments in the code itself. Okay, if you're not interested, anyways, these all these insights you'll have in this report. Nothing new. There is nothing new. Okay, so let us not waste our time just reading the comments and all. Then, what are we doing in line number 100? Try to understand it and tell me what are we trying to do. Excuse me. Friends, what are we doing in line number 100? Dropping the columns. Good. What columns am I dropping? I'm not deleting a row. I'm dropping zip code, nothing but pin code and ID column. Right. So ID column, the customer ID and the zip code, they are irrelevant features, irrelevant inputs with respect to this use case. Whatever might be, the customer's pin code, is it affecting their personal loan? The output? No. So ID and zip code columns from the data frame DF, I'm dropping them, but am I saving them? I'm not saving, but instead of saving, I'm doing in place operation. That means within the same data frame, within DF, these two columns will be dropped. So 14 becomes 12. Focus, look, 14 became 12. Clear? Yes, dropping means we are not going to consider them as part of our model building part, my friend. No more it can be used as part of our model building. We'll not include them in our model because they are not relevant. They are not affecting Y. They are not affecting the target. If they are not affecting, why should I consider them? This is called as feature engineering. Okay. Then what is the next step? Here, there is some kind of what typos with respect to the data. What no for? Okay, let us not waste our time. So there are some typos in our data. In the sense, we have experience column. Experience is representing the experience of the customer. Can experience be negative, friends? Can experience be negative? Tell yes or no. Impossible. How can a person have negative experience? But there are some typos, but a person can have zero experience for sure, right? So a customer has some of the customers have zero experience, but few of the customers they have negative experience. This is impossible. So what I'm doing is I have understood that the experience column has some kind of typos where 3 has been recorded as -3 and 2 has been recorded as -2, 1 has been recorded as -1. For that reason, first of all, I'm going to get the information of the negative values for the experience column and the value underscore counts. What are the different values that are less than 0 and what is the count is what I'm going to get. So in total there are 3. -1 for 33 customers, -2 for 15 customers and -3 for 4 customers. So this is not something possible, right? So what I'm doing is I'm applying ABS, absolute, on DF of experience. So on this data frame, within this data frame, I have experience column. So on the experience column, I'm applying ABS, absolute function, which will convert -1 to 1, -2 to 2, -3 to 3. And where are you storing this output? You are storing the output in the same column. Okay, so not only for the negative values, even for the positive values as well. Mod of x, friends, it's something like mod of -x is x, mod of x is also x, right? So when I do this, no more I'll have negative values in my data, I mean experience column. 0 is the smallest value. Yes, so 0 is the smallest value under experience. Previously I see -3, so I identified and rectified, right? Then I'm also checking for kind of null values. Do we have any null values in the data? Anyhow, we know that there is no null value, but still I'm going to check. So this should return me 0 for all the columns. Yes, 0. Clear, including the output, everything is 0. Perfect. Then this particular step is also part of feature engineering only. Let us try to understand. CCAVG. What is this column representing? What do you mean by this column? Credit card average. What is the average, monthly spending of credit card by a customer is what this particular information will be stored in this column, right? So, but if you understand properly, we also have one more column which is age, which is income. Income, are you taking the information with respect to annual income or monthly income? Annual income. You are having income with respect to annual, and this CCAVG with respect to month. So one column in year, annual, and the other column with months. So the scale is not getting, it's not proper with respect to the inputs. So what I'm doing is I'll multiply these values with 12. In an year we have 12 months, so these values are for 1 month. If I want per year, multiply with 12, so that all the columns will be with respect to annual per year. That's what I'm doing, friends. Taking the values from the data frame, multiply them with 12 and store it in the same column. I hope it's clear. We are just converting these values just to set the range. Okay, then so far I hope no questions. I'm steady and I'm very slow. The reason is I know that this particular code takes time to understand, and it gets extended till tomorrow. Okay, probably the next session. That's okay, because if you understand one use case, one real-time project, you can apply the same logic on n number of projects. You can do it on your own, friends. That is the reason I'm very slow. Right. Then what are we doing? I'm dropping personal loan. Axis is equals to 1 represent columns, friends. In columns, there is a column called personal loan. Personal loan is nothing but output. Is it right, Akhil? Yes. I'm dropping personal loan from the DF, from the data frame. Okay. And I'm storing in a variable called X. X represents inputs. X represents inputs. 5,000 customers, 11 inputs. Then from the same DF, I'll take only personal loan. I'll take only personal loan and I'll store in Y. Y is nothing but the output. So you'll have 5,000 records, and these represents the output for the inputs that we have in X, 5,000 rows. Why did you separate both of these two, Akhil? We'll understand, friend. Okay, so till this part, I want you guys to be clear on. Okay, the rest of the topic will be continued tomorrow, because we did not start the model building part. Tomorrow, the first part will be understanding how the model gets trained, then the evaluation metrics, and finally the deployment. Right? So I don't want to start the model building part because it takes time, and this is what we do for model building, and SMOT will be applied. Everything we'll discuss tomorrow. Right. So if you have any kind of technical questions, yes, all you friends, any technical questions will be answered. Is it clear? No questions for the day? I hope, you know, thank you so much. I hope it's very clear, right? Or do you have any kind of questions? If I start talking about the model building, it takes time, so that is the reason I'm not extending. We'll discuss it tomorrow and we'll conclude the day. But friends, one sincere request from my side: If you have attended today's session, don't forget to or don't join late in tomorrow's session, because in tomorrow's session I'll start directly from model building part. Okay, so immediately you're supposed to join around 7 or 7:03 or probably there. Okay, yeah, there are n number of automated EDA libraries like pandas profiling. There are n number. So there is a library called Lux. Okay, so there are n number, and I think feedback link has been shared. Neural networks we are going to cover in the next topic, because we are running out of time. That particular topic will be covered in the next program. The next program we'll discuss, friends. Friends, the feedback link has been provided in the chat. I request everyone to give your valuable feedback before you leave, and also hit on the like button. If no questions, thank you so much for joining. And you guys are really amazing for making the session interactive. Any live AA program in the next month, we are starting the classes, okay, physical classes, and you can join us tomorrow in the next month offline batch as well if you are interested. How many sessions are remaining? Tomorrow will be the last session. Tomorrow will be the deployment phase as well. So probably might be there is only one class left out. That's it. Yep. Questions. See, spider is just for your understanding. That's it. You need not focus whether it will be available in future or it gets outdated. You should focus on Python. Spider and Python both are two different things. How you are comparing these two, my friend? From 17th of this month, we are going to start a new program on Power BI end to end. Okay, so I hope everyone will join those sessions, and you know, you guys will make those sessions amazing. By the way, you are interacting in the same way now. Uh, we'll look after that, friend. Okay, so any other technical questions? No questions. That's all. Okay. Thank you so much, friends, for joining today and making the session wonderful. And before we meet in the next class, until then, see you. Take care. And before I leave, again, I'm telling you 100 times, do hands-on. When you do it, on any use case, you learn more. Okay, it should not be like watching movie or watching any kind of videos, right? So just do hands-on. That's it. Have a great day, friends. See you. Signing off.